Hi, welcome to another Getting Started video. It's a follow-on from the Industry 4.0 in 1-bit video. And in that video I show the example of this light switch, and I show the type of stream of data we might get. We could invert that and it would be just as valid. We have off at the bottom and on, two states from a single bit. And we can we can derive cycle time. And we can take cycle time as being from the rise to the next rise, or equally just as valid, we can actually take the cycle time as being from the fall to the fall. So that's the transitions between 0 and 1, or 1 and 0, and equally they're both as valid. And we can actually make some names for that. We can call that a busy time and an idle time. But if we just look at cycle time, it's the busy plus the idle, so we don't have to necessarily have a distinction between them. We could, if we wanted to look at idle time as being the transition between the sort of the 1 to the 0, essentially, or sorry, the 0 to the 1, in this particular case, depending if we're looking at positive or negative logic. The shift start and the shift end times are also very interesting, and this gets us onto the concept of what we're going to talk about today, is where do we calculate cycle time and where do we keep our shift start and our shift end times. Those bits of information we need to have available to us if we want to calculate utilization. So where do we calculate cycle time? Well, in the demo system we do it in this insert function, this one here. In our demo system we use Node-RED to calculate cycle time, and in our production system we use the database. There's also another reason for that. In the production systems we save our complete event stream. In our demo system we actually write our cycle times to the fact table, and we'll see that difference in a second. So let's have a look quickly at Node-RED. What we have is this function block. What it does is it takes our existing stream of our MQTT data, and what it does, first off it makes sure that we have this global XB variable that's length 2. If that happens, we're happy, and that's because we have our data. Now I might need to move the inset still down now, and we can see that we have our XB array here called XBs, and we make sure that's length 2. We have that, we covered that in another video. We then look at our payload. Now our payload is the data that comes from our MQTT stream, and that's essentially an array. If you recall, it has the XB ID, it has the data, and it has a timestamp. If the data is a 1, then what it does then, it sets this variable D, which is converts our payload 2, which happens to be the timestamp, to a date format that can be used later on. You then take our process key and we make that up, which we wouldn't in a production system. Essentially it takes the index of the particular XB and it maintains that, and the reason for adding 1 is that it's 0 based. So for the demo system, this is where the cycle time gets set, where we have a time that is from the payload, and we take away from it another time. Now that other time happens to be the previous time. So we see this note, get the time between now and the previous entry. So the reason why it's the previous entry is that after this cycle time is calculated, the current one is written to this flow variable. So let's look at that flow variable. We might need to refresh the flow variables. Let's do that. So we have two flow variables called ABCD and FABA, which are our XBs, and they store the previous cycle time. So the next time round, it's used when this condition is met here, message payload 1 equals 1. That would be either our rising or falling edges, depending on whether we're looking at the negative or positive logic, but it doesn't matter. And we use that to calculate our cycle time. So very simply, the cycle time in the demo system is calculated in this line, and all the rest of the stuff here is formatting, essentially, to ensure that when we insert this, when we use this insert function here, that we get the correct values into our database. Now, one thing you will notice here is that it's fixed. We have a fixed time zone. So I want you to bear that in mind, because that's a good marker for when we're going to look at how it's done in other systems. So let's look at PG Admin. If we move over to PG Admin, I've got some trigger functions opened. So these triggers are based on the event table, and you'll notice the reason why I've started with this one, this is a trigger that's in our Fire Dev here, which has an events table and an insert trigger function. Now this insert trigger function is essentially the same code that was in Node-RED. And what it's doing is when a new line's written, depending on what the data value is, then we either update or insert into this fact table. And that's it. So that fact table is updated. So it starts off with essentially a null cycle time, and the next time round it then gets finished off with an actual cycle time. I'll close that one now, because again this one happens to have a fixed time zone. This is the production one, or a production one, and this time there's actually a function. We've created a function which is get time zone from the XB, where we pass it the ID. So that's a much more reasonable way of doing it. In fact, this entire select string could be done as a function too, but that's another story. So that's our cycle data function, and behind it, actually, I'll just highlight that that's actually is the function that gets our local time zone. So essentially the select statements can be wrapped into functions, and that's all nice and dandy. But the takeaway message from this is that the same calculations need to be done regardless of essentially where this data is stored.